Okay, here we have an application problem that says a cable TV receiving dish is in the shape of a paraboloid of revolution. Okay, this is a perfect problem to get you to see exactly why parabolas are important. And in fact, I'm going to show you a picture here. Here's a picture of a satellite dish, just a little small one, hanging off the side of a house. The reason that this is so cool is because this is what we call a paraboloid of revolution. If we were to take like a saw and cut this right down the center, this would have just a very small bow to it. It's a very wide parabola, but it is a parabola. Now the reason that they're shaped like this is so the signals from the satellite that's way out in space are come down, and what they do is they bounce off of this satellite and they bounce right back to this central location, which is called the receiver. Now, in a regular parabola that we're looking at just as mathematical example, this would be called the focus of the parabola. So that it's just really cool as to why these things are going on the way that they are. All right, let's go through and let's work this example and see what we can figure out about it. It says find the location of the receiver, which is placed at the focus, if the dish is 6 feet across at its opening and 2 feet deep. Okay, this would be one of those really old ones that were humongous that you could set in. The cool thing here is I'm going to use symmetry to my advantage. I'm going to go ahead and I'm going to draw in a parabola that has its vertex at 0, 0, just so that I can have something sort of centered. Now it said the dish is 6 feet across at its opening. That literally means that from here all the way over to here is 6 feet. Well, if that's true, then doesn't it mean that there's half on one side and half on the other, since that's the way that I designed this? Absolutely. And it says that it is 2 feet deep. So that means that from the vertex up here to the edge is 2 feet. Now that's really nice because what that does is that gives me a point here of 3, 2. 3 in the x direction, 2 in the y direction. And that gives me a negative 3, 2 for this point right here. Just because of centering that with the vertex at 0, 0. Now, by doing that, and it says, remember, we're looking for the focus. We don't know where that's going to be. Somewhere out here is the focus. Okay, but what we do know is because this is opening up, then that means that it has to follow the formula of x minus h quantity squared equals plus or minus 4a times y minus k. Alright, now because of all of that, then we can plug in what we know. We know that h and k are 0 and 0. Now we don't know what a is, and in fact a is really what we're looking for because a is the distance from the vertex to the focus. So that's really what we want to find. Okay, at this point we have x squared equals a positive 4a, since it opens up, y. We need to be able to solve for a. So we need to have something to put in for x and y so we can have a as our only variable. That's why these points come in so handy. Here we have an x and a y. We have an x of 3 and we have a y of 2 that we can use. So that means that 9 equals 8a, or a equals 9/8. So it's actually 9/8 of a foot up to the focus.